In this video, we're going to discuss one type of quadratic word problem involving a projectile, something being launched into the air, something being thrown into the air, using a long answers question from the January 2017 Regent. We're only going to do the first part of the question because in this video we're going to discuss graphing the path of the projectile over the interval that they tell us. Alex launched a ball into the air. The height of the ball can be represented by the equation h is equal to negative 8t squared plus 40t plus 5, where h is the height in units and t is the time in seconds after the ball was launched. Graph the equation from t is equal to 0 to t is equal to 5 seconds. So we have to make some sort of a table involving the t values, time values, and the h values, the height. And they told us which t values we're going to use. We're using 0, 1, 2, 3, 4, and 5. And we have to find the corresponding h values, the corresponding height values at each of these times. To do that, we're going to plug into the equation. Wherever we see a t, we're going to plug in the t value, and we're going to see what we get for h. So for 0, we have negative 8 times 0 squared, plus 40 times 0 plus 5. Let's just punch the whole thing into the calculator. And the height at t is equal to 0 is 5 units. Let's move on to time 1. So we have, after 1 second, negative 8 times 1 squared plus 40 times 1 plus 5. Then we're just going to punch that into the calculator. Also, I'm going to speed up this part, just the writing and the punching in, so that you'll just be able to see the time values and the corresponding height values. Now we have all of our time values with their corresponding height values. At time 0, the height is 5. At time 1, the height is 37. At time 2, the height is 53. At time 3, the height is 53. At time 4, the height is 37. And at time 5, the height is 5. We now have to graph this on the graph on the left. We need to first figure out how we're going to space the time units and the height units. We see that we have about 20 lines, 20 vertical lines, but we're only graphing 6 time points. So the time values are going to be very spaced out. The height values, we have about 20 horizontal lines, and we're graphing from 5 until 53. So let's zoom in on the graph. And we're only going from 0 until 5 in the times. So we're going to put a number every 4 lines. This is going to be 0, then we're going to have 1, 2, 3, 4, this is going to be 1, 1, 2, 3, 4, it's going to be 2, 1, 2, 3, 4, it's going to be 3, 1, 2, 3, 4, it's going to be 4, and this is going to be 5. Now we have to deal with the heights. So we're going to divide it every 3 units. So the first line will be 3 units, the second line will be 6, 9, 12, let's zoom back out and start graphing the points. At time t is equal to 0 seconds, the height is 5. That's somewhere over here. It's actually graphed in a different color. It's graphed in red. At t is equal to 1 second, the height is 37. It's about over here. At t is equal to 2, the height is 53. Over there. At t is equal to 3, the height is also 53. That means that it reaches its maximum somewhere between the second and the third second. At time t is equal to 4, the height is again 37. Somewhere over there. And at t is equal to 5, the height is 5. Let's connect the points to make a parabola. And this is the graph of the parabola of the ball that Alex launched from time t is equal to 0 seconds until time t is equal to 5 seconds.